Good day, everyone. This is Karishma Gupta, Technical Marketing Engineer with Cisco Systems. Welcome to this important webinar on management of traditional three-tier hierarchical data center architectures using the Nexus Dashboard Fabric Controller or NDFC. We're going to introduce a new solution called the Enhanced Classic LAN in this webinar. So this is the agenda. We're going to first introduce NDFC, and then we go into the details of NDFC for classic LAN architectures. We'll touch upon some use cases of Enhanced Classic LAN, which is again the new solution which is introduced in NDFC 12.1.3. We touch upon a demo on both greenfield and brownfield capabilities and then head to the conclusion. So the Nexus dashboard itself is an infrastructure which is common across services like Data Broker, Orchestrator, Insights, and Fabric Controller. It's simple to now consume these services with a common platform, and we will be focusing more on the Fabric Controller or the NDFC service. But before we go into that, why the Nexus Dashboard Fabric Controller? Number one is NDFC supports a multi-architecture orchestration platform. It's focused not only on VXLAN but also on multi-site, classic Ethernet as well as routed fabrics. It supports multi-topology as well as multi-protocol. For example, if you're looking at a classic architecture, we support not only a 2-tier but a 3-tier architecture. The user can select from OSPF or BGP as a routing protocol, as well as it's multi-domain, meaning it spans from LAN to SAN to media fabrics. It's supporting now not just the data center but campus architectures as well. And with that, we also introduce support for multi-platform. For example, the Nexus 2K, 5K, 6K, 7K, 9K, MDS, iOS XC, iOS XR, as well as non-Cisco platforms. So all in all, the Nexus Dashboard Fabric Controller or NDFC is a very, very flexible solution. Now, when you look at the Fabric Builder itself, like we saw, it definitely supports multi-architecture, which means that a user can end-to-end provision data center VXLAN EVPN network or the VXLAN EVPN multi-site, campus VXLAN EVPN multi-site, as well as MSDC fabric or a traditional 3-tier LAN architecture. All of this is done by using out-of-box best practice templates, and that's what we're going to look at today. Now, before we go into the solution itself, NDFC 12.1.3, that's the latest release. And as we see, NDFC can be installed both on a virtual as well as a physical form factor. For LAN, we're also introducing a 1-node production VND that will scale up to a managed 50 switches. And we have support for a 3-node or a 5-node cluster. And again, the range varies depending on what kind of deployment you have. It can support all the way to 500 managed switches or 1000 monitored switches. I highly recommend looking at the NT capacity planning tool in order to scale out your Nexus dashboard clusters. With that, let's jump on the next section, which is NDFC for Classic LAN itself. Before we look at the solution, let's look at the journey and the challenges. So large percentage of deployments are still legacy classic LAN. Now, when we're looking at the updates that are made to these kind of networks, it's majorly deploying a new network or a VRF. And this falls more in the day one bucket. Most of these deployments don't have a controller or an SDN approach, and they have a large Nexus install base ranging from the 3K, 5K, 6K, 7K as well as a 9K. It has a variety of platforms. But now when we're looking at the challenges itself, when we are looking at big networks, maintenance of these networks using CLI becomes quite cumbersome. We have to make sure that we're ready for the latest technologies like VXLAN And infrastructure readiness for VXLAN adoption is definitely one of the biggest challenges I've heard from our customers. While customers are getting ready and comfortable with VXLAN, there definitely arises a need of coexistence and proper workflows of migration from classic LAN to VXLAN. And with that said, since a lot of platforms which are older, like the Nexus 5K and 6K, which are end of life and end of sale, we definitely do recommend refreshing them with the 9Ks. But we have to make our infrastructure ready for all of these modern technologies and platforms, which is again one of the biggest challenges. Now, when we're looking at NDFC for classic LAN itself, why are we developing a solution? Why are we coming out with a new product in order to support classic LAN architectures? Number one is that we would like to provide investment protection for existing networks to our customers. We also want to make sure that we're supporting standard networking protocols, and with that, providing a very minimal learning curve in order to start using a product, a brand new product, a controller approach, where it's not too difficult for the customers to learn how to move to an SDN approach for operations, provisioning, as well as maintenance. Now, NDFC itself, as we look at, supports not just deploying a brand new fresh network, but also supporting what's in the network currently, and that's the existing automation for brownfield networks. And all of this again is done using templatized best practices. So everything Cisco recommends, that's what we templatize, and we make it easy for our users to use these templates for day 0, day 1 and day 2 features. With that, we introduced the enhanced classic LAN in NDFC 12.1.3. This solution was actually beta in NDFC 12.1.2, and now we've taken it to production. Now, what is enhanced classic LAN? It's basically provisioning of 3-tier network, and when I say 3-tier, it actually also equally applies to a 2-tier or a collapsed core kind of network. Now here we have the need of user to actually just tell us that, look, this switch is an access, this is an aggregation, this is a core. Provide an intent with respect to VPC pairing, for example, spanning tree, FHRP, routing between the aggregation and core. All of these are auto-populated but can be customized. With providing very minimal intent, all of this is converted into configurations. Now, when we're looking at the configurations, we don't just stop at day 0. Once the network is up, there is a need to deploy layer 2 as well as layer 3 networks and VRFs. We have VRF Lite, which is again best practice recommendation between the aggregation and core for routing. All of this again has been templatized, and that entire template and best practice is embedded into the solution that's called Enhanced Classic LAN. We have a new fabric type that has been introduced for Enhanced Classic LAN. So every time we create a fabric, we're able to now see Enhanced Classic LAN, which is basically the solution that we're going to focus on. Now, for the very first time for Classic LAN architectures, we have added full support for brownfield, which means that the users will be able to import their existing switches into a fabric with the preserve config equal to yes option, and everything, the interface as well as the global level configurations, will be picked up and learnt by NDFC, and the user can now incrementally start managing these configurations. We did have support for host port resync for the legacy Classic LAN fabric type that has been shipping with NDFC for a while now. However, it wasn't full support, it was only interface level brownfield. So with Enhanced Classic LAN makes it a whole lot easier with the introduction of full support for learning the intent. Now, before we go into Enhanced Classic LAN solution itself, let's look at some of the big use cases as to why is the solution helpful for me. The very first one is SDN adoption for Classic LAN networks. Now, like we saw, the journey of most of our customers, most of the deployments are still on Classic LAN, and these are being managed by CLI. Now, with that, with a very minimal learning curve, these networks can be imported into NDFC and as we saw, due to the whole support of brownfield, it'll be a non-disruptive import. So everything will be picked up as is, and from there on it can be incrementally managed by NDFC. This applies to also brand new networks and switches that can be freshly deployed using the greenfield deployment. And again, this is also supported for power on auto provisioning or bootstrap option. The second big use case here is the refreshing of the Nexus platforms. Now, a lot of data center customers who are on classic LAN still have older platforms like the Nexus 5Ks and 6Ks sitting at the access layer. Now, these platforms are connected to the Nexus 7Ks in general, which are acting as the aggregation and core platforms. Now, with Enhanced Classic LAN, we are providing an ability to migrate or get away with these older platforms like the 5Ks and 6Ks and move to newer Nexus 9K platforms. So these can be freshly deployed using templatized best practices, whereas due to the support of complete brownfield, the Nexus 7Ks can be preserved if that's the intent. So the Enhanced Classic LAN gives us an opportunity to refresh older platforms while keeping or providing investment protection for platforms which are expensive and powerful like the Nexus 7Ks. So for example, this is how an older legacy classic LAN network looks like, where our access layer is comprising of the 5Ks or 6Ks. We also see FEXs attached to these access switches, and the access layer is attached to the Nexus 7K, which is in the aggregation, and the core again also acting as a Nexus 7K. So the way these are used, even for existing NDFC customers, the way this is being managed today is that we have our access and aggregation sitting in the legacy classic LAN fabric type, and the core is sitting in what we call the external connectivity network fabric type. Now these can still be managed. We do have templates in order to provide different capabilities, but the automation aspect is missing. The workflows for provisioning are not as polished as what we get with Enhanced Classic LAN, and of course the whole support for brownfield is also missing in this fabric type. Now when we want to migrate to newer platforms, now what we see in the orange box is Enhanced Classic LAN. So the Nexus 5Ks can be migrated to the Nexus 9Ks, and Enhanced Classic LAN can be used to freshly provision these Nexus 9Ks. At the aggregation and core, we can still keep the 7Ks, and with brownfield support, they can be moved from one fabric type to the other with zero disruption. So that is somewhat how the new design would look like. Now the third use case, which is also a very important one, is the moving or migration to newer technologies like VXLAN. Now this is for customers who are actually planning to migrate their workloads to a more evolved VXLAN network, but today they are on classic Ethernet and they want to provide or learn a way to migrate this in the most non-disruptive fashion, as well as with a very small learning curve. So in all, just make it easy for me to move from classic LAN to VXLAN networks. With NDFC, what we can help with is importing and discovering the classic LAN networks as we just saw, but also deploying fresh, brand new VXLAN networks as well with the Nexus 9Ks. And again, just like classic LAN, we do have workflows and templatized best practices for VXLAN as well. And until the customer is ready to move the workloads to VXLAN, we also do provide an option to have coexistence of these two disparate kind of technologies as well with the same NDFC cluster. So you don't have to change your cluster, you don't have to change your environment, you can have both coexist, and when you're ready to retire the classic LAN, you can absolutely do so. So with NDFC, VXLAN deployments in a few clicks, you can go from unprovisioned to Cisco best practice implemented VXLAN fabric, complete leaf spine architecture, day 0, day 1 functionality, all of that again taken care of by NDFC. Now this is a VXLAN EVP and multi-site design where if you have dispersed networks, like for example you have your classic LAN sitting in Asia and you want to move to VXLAN in America, you can actually have or use VXLAN, EVPN multi-site between these two types of networks, and that's what this design is depicting. Of course, this is a little more involved and I won't be covering this in this webinar. However, we have white papers to cover in-depth design and provisioning options for this kind of coexistence. With that, let's move on to our demo and look at Enhanced Classic LAN in action. So in the demo topology, we have one fabric which is considered greenfield fabric. We'll bring it up from scratch, where we have our access and aggregation switches, and we have VPC in the ag layer. And for the accesses, these are either single attached or dual attached to the aggregation. So that's what we bring up from scratch. We have an existing fabric, that's a brownfield fabric. Here we have back-to-back VPC, as we see, between the access and the aggregation, and we also have VPC pairing between the ags and between the access switches. So these are some of the topologies that are quite common that we see in the classic LAN world, and all of these would be supported in the enhanced classic LAN. Now, in both these topologies, as we see, the aggregations are connected to the core fabric. So we have a separate fabric for the core, and we will be using the external connectivity network fabric for the cores. The reason for that is the core fabric is actually shared between these two fabrics, right? So usually core layer is a shared layer, and here that's why we have two separate fabrics for our access and aggregation, while they all connect back into the core. So that's the full topology. Now, of course, all of these can be added to a fabric group as well. So with that, let's move on to our NDFC. So this is my Nexus dashboard fabric controller, which is running on the Nexus dashboard cluster. And here, let's quickly look at the core fabric. So this is an external connectivity network fabric with a BGP AS number defined, right? So it's a simple fabric that will allow us to do an auto generation of VRF light between the aggregations and the core. So we have two core switches here with the role core. Now the VRF light auto will be supported not only for core but for edge roles as well, as long as these are Nexus devices. So here we have the core fabric. Now let's start with creating a greenfield fabric first. Now we're going to use enhanced classic LAN fabric type, and we have several protocols here: eBGP, OSPF, none can be for static routing. We have FHRP options. I'm just going to stay with the default, and I am going to input a BGP ASN here. For spanning tree, I'll keep it again default, but we have rapid, MST as well as unmanaged option. Likewise for VPC, which all abide by the Cisco best practices. Now for the sake of this demo, I'm going to disable the reload for this option, because it just takes a bit longer if we reload and clean up the switch. I'm also going to go into resources, and as we see here, we have support for both V4 as well as V6. I'm going to just change the pool for VRF light. That will be the IP range that will be used for VRF light. So that's basically what is at a fabric setting level, right? I've created the fabric, but of course none of these have any switches. So the next step would be to import the switches. So we input the seed IP address, the username and password, and the number of hops, and the preserve config option will be unchecked since this is greenfield. So we'll wipe off all the configuration except for the default ones like the management IP for reachability of these switches itself. So I am going to import AG 3 and 4, which will be VPC paired, and then I have access 3, 4 and 5. So 5 switches that will be part of greenfield. So of course this is going to take a bit longer, because what it's doing is it's importing, discovering the switches, and it's wiping off the configurations, because again, since we did a disable of the preserve config, we are not reloading the switches, only for the sake of the demo. Of course, it's absolutely recommended that we do that. Now what we'll do is, at the same time, we will go ahead and create another fabric, this time for brownfield, right? So we want to look at both the options. So I'm just going to create a second fabric. Likewise, I'm going to pick the enhanced classic LAN fabric type, And here this time we have to be mindful of the settings that we pick, because it has to match what's in the switches, right? So this is, I have EBGB running between my aggregation and core. The AS number that I have in the switches that's already configured, right, is 65535. For spanning tree, again, I'm going to keep it as default option. So will the VPC, because that's what I have configured in my switches, right? And then in protocols, again, I'm just going to keep it at default, and the advanced settings, right? So all of these basically are the fabric level settings, and they remain the same whether we do greenfield or brownfield. So here I created the brownfield fabric. Now in this case, again, we're going to go ahead, run the same operation. We'll start importing the switches. This time I have 4 switches here, right? And we will preserve the config this time, since this is brownfield. So let's go ahead, discover the switches, and again we have 4 of these. That's what I'm going to go ahead and add into my fabric. And here we see the preserve config option is set to enable. So like you see, the steps are pretty similar, except for that big flag that we have there, which really determines whether you want a greenfield or a brownfield import. So here again, what is happening is the switches will not be wiped off, the configurations will be preserved, and at the same time NDFC will start learning what's in the switches and really start importing those configurations as templates into the controller, so that these can now be incrementally managed. So that's what's really going on in the background. And since these have been added, I am going to go ahead and close it. As we see here, what we have is 2 access and 2 aggregations, and the default role here is access. That's basically the default in this fabric type. So let's look at the topology. This gives us a better pictorial representation of what's going on, right? So we will just select hierarchical, and as we see, all of them are in the same level only because all of them are access. So I'm going to make the ag switch as an aggregation role, and I'll do the same for my second aggregation. Now what we see here is VPC, right? So the switches are already VPC paired, right? And that is because we already have these connected, and that's what is being discovered as part of brownfield. So that's basically the biggest operation in brownfield. Okay, so those were some operations. Really just setting the role was the only one. Rest NDFC has discovered. So I'm just going to go ahead and do a recalculate and deploy. And at this point, what it really does is it is going to go and check the configurations against the fabric settings that have been defined. It checks the rules. It checks that what I've given as an intent in NDFC is what is residing in the switch. So it's going to, as we will see shortly, it will generate a diff of the running config and the expected config. If there's anything pending, we'll get a full preview of what needs to be pushed out. So that's the brownfield operation. So let this go on the other window. We will move on to greenfield fabric, since now our switches have been added. So now what we will do is I will go ahead and run the same operation for greenfield, where again I'm going to set the role for my aggregation devices. And again, we can do this from the topology or the tabular view. In my case, I have VPC between the aggregations, and that's actually mandated. So that's what we will be doing here. And my access switches are just connected to the aggregation. So there's no pairing, there's nothing else really required here. So I'm going to go ahead and now do a recalculate and deploy. So this would take again a little bit for it to generate the configurations. It's going to, now for greenfield, it will be a lot more configurations, right? Because it's generating everything from scratch. There'll be hundreds of lines of configurations, as we will see. Okay, so here we see a preview of the greenfield fabric switches, right? A bunch of configurations with VPCs, we have spanning tree root and all of those configured. I'm going to go ahead and do a deploy all. So this is going to deploy all fresh configurations based on the roles, based on the fabric settings, the VPC pairing, everything will be accounted for and pushed out. So that's how we build a greenfield fabric using the enhanced classic LAN fabric type. Now let's go ahead and check on the brownfield fabric. So here again, the config preview, it's showing us no lines of configurations because pretty much everything is in sync. If you look at the pending configuration, left side is a running config, right side is expected config, and it's pretty much the same. There's no diff, so the brownfield has been successful, and I'm going to go ahead and close it. So now with that said, let's go into the fabric view and see what exactly was learnt as part of brownfield import. So here now my switches are all looking good. I have the roles defined with the VPCs. Now the other thing is really in terms of learning, right, as part of a brownfield, we have really discovered that the interfaces itself have policies mapped to it. For example, you'll be able to see exactly the configurations learned for pretty much every interface, whether it's a port channel, whether it's a VPC pure link configuration. All of the existing configurations were mapped to a policy, and that's what we see being mapped against each interface. So that's a big one where it's a non-disruptive operation. We just go ahead and learn all the configs for interfaces. Likewise, pretty much everything at a resource level, whether it's an IP, whether it's a VLAN, whether it's a network, VRF, all of those resources have also been learned from the switches, and we put it in the resource manager, where again we're going to maintain a repository that these are the used resources so that they are not reused or there's no conflicting use of these resources. So that's again a big solution as part of brownfield import in Enhanced Classic LAN. If you look at the networks, again all of these networks, whether they're layer 2, whether they are mapped to a default VRF or a custom VRF, whether they are V4, V6, all of these have been learned. So if we click on any of these networks, again we'll be able to see the ports that these are attached to, right? We are seeing that these are, for example, this one is attached to 2 ports on the aggregation. Same way for the VRFs, we have learned all the VRFs that were already existing. So pretty much everything has been learned. Now if I want to go ahead and create a new network or a new VRF, I can absolutely use NDFC to do that. So that was a brownfield fabric. If you go into the topology again, in order to look at the configurations, let's look at that. We have 9 networks, we have 4 VRFs. So if I click on the networks itself, I can see exactly what switches these networks are attached to, right? So that was for VLAN 32. Now if I click on another one, as we see again, we see where these are attached, right? So there's different ways to visualize it. So that's a brownfield fabric and everything looks correct. We have a back-to-back VPC again, all discovered, so we don't have to push out any configurations. Let's go check. Our greenfield fabric also looks good. We have all our switches, the VPC is all done up. Now here again, of course, we have no networks and we have no VRFs. So let's quickly go ahead and look at the workflow to create a network. Now this can be a layer 2 or a layer 3 network. I'm going to create a layer 3 network with a custom VRF. So I'll let NDFC propose a VLAN for it, and I'll leave all the fields at default. So that was the VRF creation. I will have NDFC again propose a VLAN, and this will create an SVI in return. Now here I'm expected to give the virtual IP, of course, because this is a layer 3 network, right? So that's a virtual IP, and here I'm defining the IP address of what is going to be on the active and the standby. So we haven't yet selected who's the active and who's the standby, so wait for that. We go into the advanced and we can select the HSRP version, the priority, all of those are configurable. So let's go ahead and create that network. It's mapped to a custom VRF. Now we'll attach it. So we go into the network attachments and let's pick that. So you click on attach, and as you see, the active is auto selected based on hashing. I can select the host facing ports on the access switches. So let's select ETH111, since these are attached to the end servers, right? So these are mapped to that VLAN that was defined. So here we have the status going to pending, and go ahead and do a deploy, and let's see the configurations generated. For the access switch is pretty straightforward. We're allowing the VLAN, we're adding the VLAN on all the ports all the way from the host to the aggregations. Whereas when we are looking at the aggregations, of course, the big part here is to create an SVI with HSRP with the priority. And since Act 3 was my active, you see the priority has been defined here. And we're also creating the VRF. We are creating a BGP instance for that VRF. So that's the configuration that will be pushed out from NDFC. And that's a workflow for the network in VRF. Now, this was just an example. Of course, I can create a layer 2 network as well. I can create a VRF Lite extension between the aggregation and the core. So all of that can be done here too. Now our creation of network and VRF, these were successful. So now if we go back into our VRF section, what we can do is we can also extend this VRF using VRF Lite. Alright, let's go into the edit of the attachment of VRF, and this time we'll say extend using VRF Lite. As we see, there has been an auto detection of connections between the aggregations and the core. So I'm going to say attach all because that's where I want to extend my VRF Lite. The destination, the source IP address and the interfaces, all of that will be auto generated. The configs will be auto generated. All we need to do is we need to input the IP addresses that we need on the SVI for our VRF. So let's input that and let's go ahead and save this. Alright, so here we see again the fact that it went into pending. So I'm going to go ahead and do a deployment. Now this time you have to remember that this config is not only associated with the aggregation but also the core. So here, of course, what the first thing to notice is that we will be creating a sub interface for VRF Lite, right, towards each of the core 1 and core 2, and we have a BGP session, an eBGP session between the aggregation and the core, right? So that's basically what's happening here. So that's for the aggregation. We go ahead and do a deploy. Likewise, we will have similar configuration generated also on the core. So if we see here, our core went into pending. So I can just go ahead and do a deploy here, and we'll see very similar configurations here. We'll have sub interfaces towards each aggregation, and we'll have the BGP session as well for the peering. So let's go ahead and do a deploy all. So that's basically the workflow for VRF Lite, and again all of these can be done and auto generated as long as the core or the edge device is a Nexus device. So here that concludes our VRF Lite, and that actually concludes our demo on Enhanced Classic LAN. So that was a quick demo on both brownfield as well as greenfield capability of Enhanced Classic LAN. Now let's look at some of the topologies that are actually supported as part of the solution. So what we're looking at in the screen is a typical deployment with layer 2 at the access and the aggregation acting as a layer 2, layer 3 demarcation or boundary, and usually the core is all layer 3. Now there's typically routing between the aggregation and core, whereas all layer 2 aspects like spanning tree, etc., between the access and aggregation. So of course there's full support for this kind of topology, and that's of course also our first option, where we call it a 3-tier with access, aggregation and core. However, there are a lot of deployments where there's also a collapsed core kind of scenario where our core and aggregation are collapsed into one layer, and that's what we call a 2-tier classic or hierarchical network. This is also very much supported in Enhanced Classic LAN. Now when we're looking at the variations of topologies, of course, again, there can be different kind of connectivity between the access and aggregation. It can be single attach, it can be dual attach, or there can be back-to-back VPC. And these are some examples of, again, what is supported and the different kind of variations in terms of the topology in Enhanced Classic LAN. Now these guidelines and limitations definitely apply as of NDFC release 12.1.3. Now we've looked at the support for greenfield and brownfield. However, Enhanced Classic LAN does have a mandate on the platforms. We do support FEX, the 7K, 7700 and the 9K platforms only. There's no support for the 5K and 6K. If that's a platform you have, we definitely do recommend that you use the legacy classic LAN type and plan for the migration. All of these details are also included in a white paper that we have published on Enhanced Classic LAN. Now the topology is supported. We went through this with 2-tier as well as 3-tier. However, one thing to note is that we do mandate VPC at the aggregation or the collapsed core. The reason for that is this is Cisco best practice. It's for optimal forwarding, and that's why we mandate it in Enhanced Classic LAN. Now there can be multiple aggregation pairs as well in the same fabric with no overlapping VLAN, and this scenario is only supported in greenfield. There is no support for in-band management and in-band POAP. We do have support for both out-of-band management and out-of-band POAP for the switches in Enhanced Classic LAN. Also, as we saw in the demo, there is support for auto VRF light between the aggregation and core. But just a point to note is that that's when the core and the edge roles where the VRF light is equally supported. These are Nexus switches. As long as end-to-end it's a Nexus family where we're looking at the access, aggregation as well as the core, it's all auto VRF light. In case you have a non-Nexus platform, for example an ASR platform, again you can definitely use the templates that are shipped with NDFC for a manual auto VRF light as well. So these are some of the guidelines and limitations to keep in mind as of NDFC 12.1.3. Now when we're looking at the day 2 features, right, so we saw how to bring up the entire network, how to define the role as access, aggregation and core. We have spanning tree, FHRP, routing aspects, networks, VRF light, all of those things kick in, and these are called the day 0 aspects. Day 1 is when we are looking at deploying or incrementally managing this in the network, for example, having a new VLAN that has been deployed on the host facing side, and we need to allow these VLANs end to end, right? So this is more like a day 1 feature, for example. But now when we're looking at day 2 features, there is a lot that comes into picture when we're looking at the visibility and maintenance and operational aspects as well. So this is a little summary on the day 2 features where we have support for enhanced RBAC. So there are a lot of roles that are defined at a Nexus dashboard level. For example, a user can be an administrator, a stager, an operator, an upgrade admin, or an approver or deployer for change control. Now these roles can vary depending on the type of fabric you want to provide access to. So for example, someone can be an administrator or a stager for one fabric, and can be a stager and an operator for another fabric. So it's totally dependent on and boils down to a fabric level. We do have support for change control with ticketing mechanism as well as rollback, which is introduced in NDFC 12.1.3, and this is very much supported agnostic of the fabric type and hence absolutely applies to Enhanced Classic LAN as well. We have support for upgrades, RPMs, patches. All of this is done using our image management workflow, and this can be done for all devices, all the switches in Enhanced Classic LAN. We have view into the inventory as well as the topology, as we also saw in the demo. We have an operational as well as a configuration status. So if you're looking at managing something from NDFC and there's someone who goes and makes an out of band change using CLI, which isn't locked by the way, but if that happens, there will be an out of sync status that will be detected and marked in the configuration status of that switch by NDFC. There's event analytics, deployment history, audit logs that are available. We do have support for backup and restore at a fabric level or at an NDFC level, performance metrics, links, interface stats, protocol views is what's available for the switch as well as the fabric. We have programmable reports which can be run at a cadence. You can decide what kind of switches you want to gather data for For example, for SFP or inventory or performance data, this runs at a cadence. It's equally programmable, as the name suggests, and can be emailed out as well. Not only for the network side, but we do have full support for visibility of the virtual infrastructure like vCenter, Kubernetes, OpenStack. So all of this visibility is basically an integration that is provided at an NDFC level. And now you get visibility not just into your network, but your virtual world as well. Now let's look at some Day2 features in detail. For example, here we have the deployment history under the history tab per fabric. We're able to see the deployment history, meaning what commands were pushed out by who to which switch, when. We also have the policy change history, which maintains a history of the policy or the templates itself. Under the topology view, we have already seen this kind of in the demo, where NDFC will learn the topology as soon as you discover the switches. It'll import and learn the links, the interfaces that connect to switches and form a link. All of those are discovered, and then it continuously maintains an operational and config view, which is all real time, that can be seen in the topology view. In case something goes wrong, then of course that is also reflected in terms of the events and performance data that we look at. Here we have the event analytics. For example, under the event analytics, we have alarms, events, accounting logs, and we also able to see these across the clusters, which is what we call federation of the different ND clusters that host NDFC. So that's also possible. In the alarms, of course, if something goes wrong, then we're able to look at a particular alarm. We can also create our own alarm policies with certain thresholds at a device or at an interface level. In the metrics, if we look at the links tab under the fabric, we're able to see how the interfaces form a link. We're able to see the neighbors if present, the admin and the op state. We're also able to see the protocol view in terms of what protocols are active and the state of the protocol itself, the uptime. For example, this can be VPC, OSPF, BGP, etc. We're also able to look at the metrics like CPU, memory, traffic, temperature, interface, and links. This is what we call the performance data. We need to enable performance monitoring under the features tab when we start our NDFC instance. That is the first prerequisite for this. And when we're creating a fabric, we need to enable the performance monitoring tab under the general tab in the fabric settings. So those are the two things that we need to check, because it's not enabled by default. But once that's done, you're able to look at all these metrics, and again, this is available per fabric. So you can enable or disable them. This is all based on SNMP. Now, a very important customer use case is image and patch management for NXOS. As we all know, this can be quite complicated, it can be slow, and there can be various things that can go wrong. So in order to simplify and speed up and mitigate errors, we have the image management workflow, because upgrading manually does take time and it is actually prone to a lot of errors. Image management workflow in NDFC itself will automate the whole process, and you're able to select or upgrade or downgrade or apply patches to a switch or a group of switches, and you can also do it scheduled or on demand. Now let's look at an overview or the workflow of image management. The very first thing that we need to do is get the software. It can be an NXOS image, it can be an RPM or a patch from software.cisco.com, and make sure these images are uploaded into our Nexus Dashboard Fabric Controller or NDFC. So that's the very first prerequisite. The second is an image policy, which really defines the intent. It tells NDFC the user intent in terms of what needs to be done. For example, a particular set of switches need to be upgraded or downgraded to an NXOS image. Next thing is we attach this policy to, again, it can be a single switch, it can be a group of switches. We do have full support for upgrade groups as well, where we do a lot of checks around the roles and the prerequisites of actually creating the group of switches. Now, once the policy is attached, the user can stage the images, which really means that you're copying the images to the switches. And you can also have NDFC validate a non-disruptive upgrade. It'll check for a non-disruptive upgrade. And if things look okay, you can actually go ahead and hit the upgrade button, and that'll go ahead and upgrade the switches. Now, while all of this is going on, of course, NDFC also has live install logs, so you're able to see exactly what's going on each switch, and if something fails at any point, you're able to see exactly what the error was. So all of this is all done using the NDFC image management workflow. Now let's look at the RMA, or the return of material authorization workflow. Now this can be done using POAP or a manual RMA flow. The very first step is from the fabric, we select the concerned switch that we need to replace and change its mode to maintenance. That's how you will gracefully take out the switch from the fabric, and all control plane traffic will be deterred from being sent to that particular switch. Now you replace the old switch with a new one, and you select the admin password in case you are POAPing the switch. You select the device to replace it, and you click on provision RMA. That will basically restore the configurations from the old to the new switch. And thereafter, once this is done, you can actually move the new switch back to normal mode. That takes around 5 minutes for a full configuration. Now we also have programmable reports. We briefly spoke about this during the webinar. The programmable reports itself can be run at a cadence, and this can be run for a switch or the entire fabric, meaning for all the switches in the fabric. There are a lot of programmable reports that are shipped out of box, and this, for example, we're looking at performance report, which really includes the CPU memory, links data, and ports data, and you're able to see a graphical representation of this data over a day. So you're able to see the spikes, you're able to see the minimum, maximum, average, and just like this, we have the report for SFP, inventory, and the user can also go ahead and create their own report. As the name suggests, it's very programmable, so it's very flexible, and you can run really any commands per your needs on demand. Now we have the visibility into the virtual world along with the networking world, right? So for example, if you're looking at virtual machine manager visibility, we have visibility of the access aggregation core or leaf or spine, and that's definitely possible in the topology view as we saw. However, if we are able to add your vCenter into NDFC, it does a read-only access of the vCenter instance, and it goes ahead and picks up a lot of information like the virtual machines, how these virtual machines reside in your virtual switch or distributed virtual switch, how these are connected to your physical host or your UCS server, for example, and how these servers itself are connected back to your leaves or your access. So this is all possible just on a click. If you add your vCenter instance, provide the username and password, NDFC will go fetch this data. Likewise, we also have visibility for Kubernetes, where all the way to the pod. So the pod namespace, the Kubernetes node, again, how that is connected to your distributed virtual switch, how that's connected to your physical host, and how that connects back into your network. You have that visibility using this integration. So again, you just need to add your Kubernetes instance, giving it a username and password in NDFC, and it does a read-only access. Now this is a huge value add, because not only for your network but also for your virtual world, you're able to see the connectivity and you're able to analyze and manage that connectivity. You're able to see what may be wrong. So that brings us to the end of the session. Now let's look at some of the important points that we covered during this webinar. Now, enhanced classic LAN was the topic of the hour. This is really introduced to help our customers migrate from a CLI managed classical Ethernet network to an SDN approach or a controller based approach with NDFC with very minimal learning curve. You have role-based provisioning for access, aggregation, and core. in just a few clicks. We have full support for not just greenfield but also brownfield. This does provide investment protection for the Nexus 7 case that exists in your current network, and also provides an opportunity to refresh the older Nexus platforms like the 5Ks and 6Ks to the Nexus 9 case. That was it from me. I take off. Again, this is Karishma Gupta. Thank you for watching.